All right, welcome to chemistry lesson 6.04 over hybrid orbitals. Just when you think you've got the hang of these darn orbitals, they're going to go and change on us a little bit. And so that's what we're talking about in this video. We're going to start off with bonding versus non-bonding electrons. And I'm going to do the orbital diagram notation and the Lewis structure for carbon tetrafluoride. So let's start off with carbon fluoride is CF4. So when I want to do my Lewis structure, I'm going to put carbon in the middle. I'm going to surround it by my fluorides. And for our total electrons, when we calculate that and do our structure, we end up with, and you've probably already done this in your practice problems by this time. So each fluoride has 7 and a carbon has the structure you end up with. Well, if I want to do my orbital diagram notations, so carbon has 6 electrons. I want to be careful. And fluoride has 7. So we're going to go with 1s, 2s, 2p. And fluoride's going to be 1s, 2s, 2p. When I fill these in for carbon, the 1s fills first, followed by the 2s, and then 2 electrons in the 2p. And here, 1s, 2s, and then I go 3, and then 2. I'm sorry, I said 7 for fluorine. That's wrong. It's 9. My error. I don't know where my brain was exactly. Oh, I know. I was thinking about valence electrons. So we have 4 valence electrons. So these are my valence electrons here. I have 4 valence electrons for carbon, and I have 7 valence electrons for fluorine. Well, it turns out that only the rule for bonding is, let's write this down, only unpaired electrons can bond. Well, for fluorine, it's actually for fluorine, that's okay. Because here I have 1 unpaired electron and I'm forming 1 bond. But we've got a problem with carbon. Check out carbon's bond. I've got 1, 2, 3, 4 bonds. And if you remember from biology class, we talked about the fact that carbon can form 4 bonds. But according to this orbital diagram notation, I only have 2 unpaired electrons. And according to this, I should only be able to form 2 bonds. So we have a problem. Well, the answer is in something called hybridization down here. So if we did the Aufbau diagram, so now instead of doing an orbital diagram, I'm going to do an Aufbau diagram of carbon's valence electrons. And we're just going to look at the valence electrons because remember, bonding is only valence. It's only valence electrons. So carbon's valence electrons, we have a 2s and we have the 2p. And carbon has 2 electrons here and 1 and 1. To form 4 bonds, it would have to have 4 single electrons. Well, here's what happens. So it turns out these 2 orbitals, the 2s and the 3 2p's, are very close in energy. And they're so close, in fact, that they kind of blend together and form new orbitals. So they blend together and create new orbitals. So if this and this and this and this combine together, you get, the result is four orbitals that lie between, that lie between the S and the P. So the resulting orbitals are going to fall somewhere along this line. And that's what we see over here. Now, this is a little bit faint, so I'm going to kind of outline it. And here's my 1s way down here, and we're just ignoring that guy because it's an inner shell electron, and it doesn't do anything for us. So this represents the 2s. These are the 2p. So we have the same thing over here. And look what happens between, these need outline too. So from here to here, you see how these resulting combined orbitals lie in between the S and the P? And because it's an S and then the PXY, the PX, the PY, and the PZ, so I have a P here, a P here, a P here, and an S. We call these resulting orbitals Sp3. And now we're going to feel like this. So the Sp3 orbital diagram would look like this. We would write Sp3. And what happens is we fill these evenly. This is why carbon can form 4 bonds. According to its original S and P orbitals, that can't happen. But down here, when these combine, you get these Sp3. So here's another example. It doesn't have to be 1s and all 3 of the p's. Sometimes, for example, down here, so let's do an example 2 and I'll change colors. My s orbital, so I have, let's say this is a 2s. And here I have, this is a px and this is the pz. So I have 2 of the p's. Sometimes only these first 2 will hybridize. So you get an S and 2 of the P. And when that happens, your result is going to be, whoops, go back to green. Oh, well. You would have an S and 2 P's, and then up here you still, one of your P's is still floating around. When that happens, we call that Sp2 because I have 2 P's and I have an S. If just an S and just a P hybridize, that's called Sp. So you have, when we look at this hybridization and we're talking about Sp hybridization, you could have 1 s orbital and 1 p orbital. Let's write this out. So if I have 1 s orbital plus 1 p orbital, it's going to give me Sp. If I have 1 s orbital plus 2 p orbitals, I'm going to have Sp2. If I have 1 s orbital plus 3 of the p orbitals, I'm going to have Sp3. And we can look at the Lewis structure and we can tell what kind of hybridization we have. So for example, if we look at carbon, it has 4 bonds around it. That means it has to have 4 orbitals. And if you look at this, 1 plus 3, this is 4 orbitals. This is 3 orbitals. This is 2 orbitals. But before we go too deep into practice problems, we have to talk about a little bit more about kind of some of the details and the ideas behind bonding. So these 604 and 605, we're going over the concepts. And then when we hit 606, we'll do some practice, and 607 will be more applied. All right, so what are our takeaways? Only unpaired electrons can bond, and according to the orbital diagram notation for carbon, that can't happen because I only have two lone pairs. So what we know, what they discovered is that something unique happens. These guys, when you think about this blending together, have you ever done a coloring page with marker? And your two colors, if you do blue and you do a yellow next to each other, they'll blend and they'll make green. That's kind of what we have here, where we get these orbitals blending together to make something new. And these orbitals lie a little higher than the 2s and a little lower than the 2p's, or than the p's. And if we have all three of the p's in an s, we call that sp3. If I get two of the p's in an s, that's going to be sp2. If I get one of the p's in an s, that's just sp. And we see different kinds of hybridization depending on the structure. So sometimes carbon will do sp3, sometimes carbon will do sp2, and sometimes it'll do sp. And you can tell this by the Lewis structure, which we'll apply in a later video. All right, that's all for hybridization. Next one, we're going to talk about what happens when we have a double bond.